Okay, exercise 5B, question 15C. It says find an expression for PR, so that whole length, and PQ. All right, so I don't want you to give me its length to 2 decimal places or anything like that. I just want it kept in an expression form. And then we're going to find angle alpha to the nearest minute. Remember, at the moment, we're only doing right angle trigonometry. So I'm just going to sort of draw, well, look at the, I'm just going to draw this triangle again, PR, and we know that that's 40 degrees in there, and that this is 18. So you're looking at the big triangle. Can you come up with an expression for PR? What are you going to use? If you had to find PR, what would you use? There's your angle. So I've drawn the whole thing really small here. Hopefully you can see it. If you want PR, what are you going to use? Sine, cos, or tan? I want PR. Cos of 40 degrees is what? PR, adjacent over hypotenuse over 18. So when we say find an expression, so PR is just, how would I work out PR? What do I do with the divide by 18? Times? So it's 18 times cos 40. That's my expression for PR. And you actually don't need the time symbol between, so we write it as 18 cos 40. So that's an expression for PR. Now we're going to find an expression for PQ. PQ, there it is. Expression for PQ, there are 2 triangles we can use. So PQ, let's use the big triangle. So what do I use in the big triangle to find PQ? Sine. So sine of 40 degrees equals PQ, opposite over hypotenuse. So PQ equals 18 sine 40 degrees. That SR is 8 centimeters. So what do you think we can do now? Could we come up with an expression for PS maybe? What would PS be? Therefore, PS is PR minus 8, which is 18 cos 40 minus 8. So now we could, so we've come up with an expression for PS. So that's good. 18 cos 40 take away 8. Okay? Now you could work out what, I know it looks a bit yuck, but it's okay, it'll still work. All right, probably you're used to, you would normally write values here, but we're trying to practice it without writing any values, just to work with it like that. Okay, so what are we going to do now? So try and keep, so now what do we do? I'm going to move this out of the way, this other thing. Q on PS, PQ over PS, so tan of alpha is PQ, PQ. 18 sine 40 over 18 cos 40 minus 8, and then you can just put it in your calculator. Decimals, I've just kept the expressions there. I've come up with an expression for PQ. We had an expression for PR, but we know that PS is PR minus SR, which is 18 cos 40 minus 8. So instead of working these out as decimals, I've just kept them the way they are and then just substituted them in. So you can do that now on your calculator and work out what this is as a decimal. So tan of alpha is whatever. So alpha will be tan to the minus 1 of whatever that is. Okay? That is PQ over PS. We've put in our expression for PQ and PS instead of their decimal value. Then we've just worked out what that is. We get 1.99 dot 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 whatever. Alpha is shift tan, and you get 63 degrees what? 25, 26 minutes, 27, how many? 25. And how many seconds? 25 minutes, 12 seconds, which is 63 degrees, 25 minutes to the nearest minute. Look, sometimes they might say, show that tan alpha equals this expression. Do you know what I mean? So they can do that rather than you. So the only difference is we're keeping it We're keeping it in that format, and we're keeping this in that format instead of working it out. That's all. It's the only difference to what you may have done last year. Right angle trigonometry. If they want you to find x, you're going to need to find this whole length, y, and you're going to need to find this length here. I'll call this one z. And obviously x will be y minus z. Are we okay? So we're going to draw up, we're going to have different triangles. Now you can draw them up separate if you want. This will be the y triangle. That's 10. You tell me what, for the y, which is the large one, what's this angle? Go. If I'm doing y, that's the big triangle, what's this angle down here? Good. Okay. And when we come to work out x, I'll draw the smaller triangle for z, sorry, not x. So I've got two triangles drawn. The big one, so I can work out y. And I've got the small one, so I can work out z. Now, girls, you can't forget what you learnt in terms of exact values. Remember? Exact for 60, if you ever see tan, sine, or cos, 30, 60, 45, they're the exact ratios. Okay, let's go. First triangle. Let's work out y. What have you got? Well, you don't have hypotenuse, so what have you got? Sine, cos, or tan? Tan of 60 is opposite over adjacent. It's y on 10. So y equals, tell me what to write. 10 times tan 60. Okay, what does tan 60 equal? You can go tan 60, square it. What do you get? If it's horrible, you square it, you get 3, so it's root 3.
Yes, I'm just confused what the 20 over 3.
Oh, so the question is they gave you the diagram with the x there. Show that x is 20 over 3 root 3. Don't worry about that yet. We'll get there. So what we've got to do, we think, to work out x, we really need to work out, I can only work with right angle triangles at the moment. I can work out y and I can work out z. Let's just do that. Just work out y and z because x is y minus z. Are we okay with that? So do one little bit at a time. So draw your large triangle for y. Tan of 60 is y on 10. Y is 10 times tan 60, which is 10 times root 3, or we write that, you know, as 10 root 3. That's what y is. Okay, do the same in the small triangle. Go. Sine, cos, or tan? Tan of 30 is z over 10. So z is 10 times tan 30, or 10 tan 30. What does tan 30 equal? Calculator if you want. So it's 10 times tan 30, or 10 tan 30, which is 10 times 1 on root 3. So z is 10 over root 3. You okay with that? Nearly done. Now we know that x from the diagram equals y minus z, which is 10 root 3 minus, now I don't want to write that as 10 over root 3. What should I do with this? It's irrational. It's got an irrational denominator. I should rationalize the denominator by multiplying by root 3 over root 3. So this was chapter 2 stuff, which is what? 10 root 3 over what? 3. So I'm going to replace my z with 10 root 3 on 3. So y is 10 root 3 minus 10 root 3 over 3. Now you don't put the root 3's in your calculator. It's like it's algebra. The root 3's are like terms, like surds. So really you're just interested in, if that was 10 root 3 minus 5 root 3, or 10 root 3 minus 4 root 3, you'd have 6 root 3. So you're really interested in what 10 minus 10 on 3 is, or you can write the 10 as something over 3. No, you know how that's 10 over 3? Can you write this with a denominator of 3? What do you times it by? At the moment it's over 1.
Times 3.
Isn't it over 1 at the moment? So you times that by 3 and that by 3, but it's the whole numbers you're timesing by 3. Or you just grab your calculator and you go 10 minus 10 over 3. So I can say that that's 30 over 3 root 3. You okay with that? Minus 10 root 3 on 3. This is one way. Otherwise, girls, you can just get your calc out. Isn't that one denominator? 30 lots of root 3 minus 10 lots of root 3 are 20 lots of root 3. Now, if you didn't do it that way, you would just go like this on your calculator. You'd say, yep, like terms, because they're both root 3s. The only bad thing about this is the 10 on 3. If that was a whole number in front, you wouldn't have a problem with this. So you just, on your calc, you can go 10 minus 10 on 3. And you will get a mixed numeral, and you change that mixed numeral to an improper fraction, and you should get that. Try it. It does say show. They really do prefer this working out, girls. All right. Now, if I just want to keep the whole number bit separate, like that's 20 over 3 times root 3. The fraction bit in whole numbers is 20 over 3, and the root 3 can either be next to the 20 or separate to the 20, but it's on the numerator. All right. This is a balloon. This is the question. The angle of elevation from this point to the balloon is 57 degrees. The angle of elevation from, I'm going to call this point A, point B. The angle of elevation from point B to the balloon is 33 degrees. They want to find how high the balloon is above the ground, and all they've told you is that it's 1 kilometer from A to B. So we've got to do something. Anyone got any ideas? Okay. All good. Can I call this one C actually? And I'll call B for balloon. So I've got A, B. I'll call this one D in the middle. So I've got A, B, C, D there. I want to work out that height. Standing at A, looking up at the balloon, angle of elevation 57 degrees. Someone standing at C, looking up at the balloon, angle of elevation 33 degrees. We want to find the height of the balloon. All we know is that A and C are 1 kilometer apart. You have to find the height of the balloon in meters. So for a start, you change your kilometer to meters. But the problem is, the whole thing is 1 kilometer. So look, we can actually keep it as kilometers and then change at the end. It might be easier. We'll just see. What am I going to do? I'm just going to call, what if I call this one X? What would this one be? It might be easy to keep it as 1 kilometer at the moment. Let's just keep it as 1 kilometer. If that's X, oh no, we can keep it as meters. What would this be? Let's say that's 200 meters. How many meters is this? That's right, 1,000 minus whatever that is. You got it? So that's how you say it to yourself. All right, I don't know what that is, but if that was 300, that would be 700. If that's 400, that would be 600. How am I doing this? Whatever this is 1,000 minus that. Got it? So that's what you do. If they want the whole lot and nothing's broken up, you call one X, you call the other one the total length minus X. Okay, now we're going to come up with 2 expressions. Look, we're not stuck, but there's only one thing you can do. Sine, cos, or tan? Tan. So let's go. Tan of 57 degrees is H over X. Now, whether we put we don't want 2 unknowns, so I can either write what I can say that, why don't I say that H is X times tan of 57 degrees. How about that? But see, if I do it this way, I'll show you what's going to happen. We've got 2 choices. Don't worry, we'll do it both ways. What about the other one? What are you going to do? Tan of equals H over 1,000 minus X. So H is 1,000 minus X, and I need to put it in brackets, times the tan of 33. Are you okay with that? Now I can come up with an expressions for H. So I've got, this is one expression for H, and this is my other expression for H. I can now put the two equations equal to each other, and I will only have something in terms of X. But you are trying to find H. I'm going to do it both ways, all right? Because some of you might do it that way first. And if you do, that's okay. You can still get to the other answer. All right? So let's go. If H equals that and H equals that, don't they both equal each other? Yes or no? So can't I say, I'm going to call that equation 1 and this equation 2, and I'm going to sub 1 into 2, and it doesn't matter which way you do it, or 2 into 1. Doesn't it mean that X tan 57 equals 1000 minus X tan 33? Do you agree or not? So girls, what I'm doing here, I've got an expression for H here and an expression for H there. Well, H is the same H, so the H's are the same. So if H equals that and H equals that, then those two equal each other. Got the idea? Oh, jeez, my glasses. Okay, now, broke them. So expanding, X tan 57 equals, what do I do? Come on. Expand the bracket, 1000 tan 33 plus or minus? 1000 times that. Remember the tan 33 could be out the front. It's that times tan 33 minus X times tan 33. Now we're trying to solve for X. I mean, I know we're trying to get H, but we're going to get X instead. What are we going to do now? X is appearing in two places, so you take all the X's, anything with X's to the left. So I'll keep the X tan 57 here. Now what do I do? Bring over, what do I write? Plus X tan 33 equals 1000 tan 33. Are we okay with this? Now, I've got X's appearing in two places. Girls, when you come to solve an equation, you've got X over here, get all the X's together on the left-hand side, and then factorize out the X. Then you've only got one X now. X is tan 57, what do I write? Plus tan 33. That equals that. Now how do I work out what X is? Now what do I do? Don't I just, X times all of that equals that. So isn't X what divided by what? Yeah, 1000 tan 33 over tan 57 plus tan 33. So an exam question might say, show that X equals. Now I'm nearly finished. Remember, I'm trying to work out what H is. I can see here in the corner what H is. So that's what X is. I don't have to work it out. I don't want to work it out. But I know that H is X times tan 57. So instead of working that out, getting an answer, trying to save it, I know that H is X times tan 57. So isn't this what X is? So it'll be 1000 tan 33 over tan 57 plus tan 33. You can put that in brackets. That's what X is, times tan 57. Are you okay with that? That's what X is. And does the tan 57 go on the numerator? Yes, times tan 57. So I may as well just continue this and put it there. So it's actually 1000 tan 33 tan 57 over that. That's what H is. And now you can work it out.